just to give you a little bit perspective as to where we are, there are 5 ebooks that ACER has. Yeah, written it on some very advanced technology here. So the first one, we did the first unit in our last tutorial, which was GAMSAT practice questions, very generic names for their 5 ebooks. And that is a partial length book. So it doesn't have all the questions of a full length exam. The GAMSAT sample questions is what we're going to be doing today. We're going to do the first unit of that. And that is also less than a full length exam. And then there are GAMSAT practice tests 1, 2, and 3, which are actually longer than a full length exam because it's using the old format. And of course, this is the order in terms of when ACER released these booklets. So this one was first released in the 90s, believe it or not, but then re-released in the 2000s. Then this one came, then this, and this. So these are the most recent questions. So I think you've seen what our trend will be. We've done this one. The first unit, we've done this one. Next time we will do one of these as the first unit, and then one of those as the first unit. So that's the plan. However, today, what we're going to do, because you have to understand, don't worry, you're going to get used to this. I'm going to repeat it more than once, is that the exam itself feels new. So many of the questions tend to feel new. About half the questions are new every season. The rest are repeated or link questions. But it's still, most of the exam feels new, feels unfamiliar, feels different from the practice materials to some students. But that's because students are focusing more on what did the question ask rather than what did I learn from the reasoning used in that question? Because the reasoning used in the questions that you're going to see today will apply to the real exam. Will the same topic be there? Very unlikely. The same graph? Very unlikely, and so on. So we're going to start with graph analysis. And don't worry if you haven't completed your biology study, it's not important. It's the subject where you probably require the least amount of assumed knowledge as compared to the other subjects. And so if you have a nursing background, we're going to be talking about systolic and diastolic pressure, and it's going to seem very familiar as a topic, but the questions are asked in a way that everyone is sort of at the same level. And you will notice that. So there's going to be graph analysis for the ACER questions, first unit of GAMSAT sample questions. So I am hoping that you will access that from your ebook or printout or whatever. Some students still have the actual booklets, as I do. I have several from when they were first published. And sometimes they're available on eBay or Gumtree or some such thing. So the mission, should you choose to accept it, is that we will complete 6 ACER practice questions. You will be given the time to complete the questions, and then we will go through the step-by-step work solutions. And these questions are based on circulation, which is one of the most popular topics that ACER has for biology. But you'll see that's almost irrelevant. But anyway, circulation and genetics is another one that is quite popular. And then we will do 5 Gold Standard Masters Series questions, also based on circulation, and they'll be very different from the ACER questions. They will have a couple of questions that will be on graph analysis, and one of them will require you to use dimensional analysis, which is a tool that is often used dozens of times on the exam. So you'll get to use that. And this will be recorded. It will be on YouTube, so that you can, if you miss anything, you'll be able to watch it. And your mission also includes, should you watch it on YouTube, please like, comment, or subscribe, and that would be appreciated. Okay, so let's get the questions, get those questions in your hands, and then we're going to start a timer according to the new timing of the exam, because I want you to keep in mind that when you look at ACER's ebooks, they will all have the ancient timing. So don't follow the timing that ACER tells you that you should have. Follow the timing that um, that is according to the new exam. So that is approximately 1.6 minutes per question for the reasoning and humanities and social sciences section, which is much more than what it used to be, 1.3 minutes per question. You know, getting those extra minutes for an exam is very helpful, especially when there are fewer questions. And then also for the science section, now it's 2 minutes per question, but ACER used to have 1.5 minutes per question. So GAMSAT sample questions, first unit. Um, just one moment, please. Little technical thing. And you're going to have 2 minutes per question. So you're going to have for these first 6 questions, you're going to have 12 minutes. Can we have a clock, please? And of course, if you're watching the video, you can skip this if you've completed the questions within the timing. Good luck. Okay, so let's have a look at this. First, uh, in terms of graph analysis, the first things that you will normally do is you're going to check the caption. The caption says figure one. It doesn't help. But then you look at the X and Y axes and you see the categories that are being presented. These are so-called histograms, not really relevant, but we see that whatever effect there is, there seems to be a greater effect on the systolic than there is on the diastolic. And then we check the labeling of the X and Y. So we have fruit, vegetable, this and diet, and we have the Roman numerals 1 and 2, and we see below the graph that 1 and 2 relate to a blood pressure of 130/80, which we are being told this is high normal. So this is high normal. Okay. And in the back of your mind, it's not really relevant, but most people know that blood pressure is normal at 120/80, but that's not important. ACER's not asking you to know that. And then this last part we see is this part is going to be 150/95. And this part, we are being told this represents someone who is mild hypertensive. Okay, so we have those labels. We're keeping those labels in mind, and then we have to identify sort of what's going on here. We have a trend of blood pressure decrease. That's the trend that we are looking at. And realistically, when you're looking at this, because it's a decrease, but the graphs are increasing. So in reality, this graph is upside down. You see, if this graph was literally upside down, and instead of having 0 to positive numbers, instead you had negative numbers going down, then most of you would have gotten questions 2 and 4 correct. But many of you probably will get questions 2 and 4 or 2 and/or 4 incorrect because you didn't spend the time looking at the graph and asking what is the trend that I'm looking at, because it's a trend of increasing decrease. So had it been flipped on the other side and they put negative numbers going down, then it would be very easy to see what's happening. And I know that some of you say, why does ACER have confusing graphs? Why does ACER use ambiguous wording in the humanities section or the science section? And the thing is that when you're working in an emergency department and someone comes in with acute appendicitis, they don't point right to where the appendix is and say, I've had fever, nausea, anorexia, and tell you all the classical symptoms. They're going to say, I went to my uncle's place, we had a barbecue, some people, felt fine, some didn't. They're going to give all kinds of information, and you have to sift through what is relevant. And also, in terms of graph analysis, there's going to be pharmaceutical companies and surgical instrument companies who are going to send you graphs which truly are, well, some people might say deceptive, but let's say that they show minute changes, but they organize the graph in order to optimize the changes in order to market their product to you. And you have to have that cool, calm, collective sense in terms of your analysis. So ACER is not trying to test your knowledge. They're trying to test the way you think. And that appears, given the studies, to reflect how you will perform in medical school. So that's the concept. And it's not that you're born with it or you're not born with it. everything has both elements, nature and nurture, but the issue is that you practice this way in order to understand how ACER rolls. And one of their common themes is that ACER loves opposites, and we have to be attentive to that. Okay, so let us begin. We'll start with the first question, and you can put your answer for question 1 in the chat if you wish. That's question 1. And so, which one of the following to be the estimate of the systolic pressure of high normal? So we have, of course, always it's going to be systolic over diastolic, and high normal is going to be this number right here. And so we're going to put question number 1. Let's see, get this on here. Question number 1. Yes. Yes, you guys seem to have it quite well. So we have 130 over 80. And what happens to that? These are not fractions, of course. We're subtracting the systolic and the diastolic. So we have 130 over 80, and we're trying to see what happens when we go from here to here. And we started off with about 6 here. We ended up with about 3 here. So that's going to be 3. And then for the diastolic, which is here, we started off at around 3. We ended off at around 1. So that's going to be, what did I just do? We went from that's high normal person on accommodation diet. Yes. My apologies. Multitasking is a very bad thing, especially if you're studying the exam. So we have combination diet. A person started with a high normal, had the combination diet, so they're going to be reduced by 6 over 3. 6 over 3. So we would have 124 over 77. And we look at the answers, knowing that this is what we're looking at. We're looking at the systolic pressure. And so we're looking for 124, and the closest number is 125. So the answer is indeed, as you guys have stated, answer choice A. And there's going to be ambiguity in the exam. There's going to be times where you calculate something and you see that the actual answer is a little bit off one way or the other. But of course, you know how multiple choice is. Multiple choice is what is the best answer. Okay, so we move on to question number 2. Okay, now, one of the things that is helpful, both in the humanities section and in the science section, is to just take a moment, use your A4 scratch paper or your whiteboard, whichever one you're going to do, use and write out what is the rule for that unit or passage. Sometimes this is helpful. You see, the rule here is that if a person has elevated blood pressure, so either high normal or mild hypertensive, then we are noticing that there are 2 things that are possible. If you increase your diet, you decrease the blood pressure. Okay, so a person who is high normal, who has a diet, we see that the blood pressure decreases. So I know for many of you, question 1 was very easy. But I want you to keep in mind that during the exam, sometimes ACER will give you an easy question so that you see the trend, and then the next question may be more difficult. So keep in mind that if you see a question somewhere within a passage and you feel lost, you're not sure how to start or whatever, then go back to the previous question or possibly even the question before that. And sometimes you will see the clues that will lead you to answer a question that is more difficult. So we see increased diet leads to, and less diet, therefore, the trend is for an increase in blood pressure. And we can see that as we go from combination to fruit and vegetable, or fruit and vegetable to combination, we can see this trend. Once you have this rule, you can always check yourself that you didn't switch things in your mind. Okay, so let's go to question number 2. So question number 2, you can put what your answer is in the chat, and then we will discuss it. And question number 2, you can see that A and B are in exact opposition. Often professors will say if two things are in exact opposition, the answer probably is one of those two, but that's not always the case with ACER. Might be the case in this instance, but not always the case. So we want to see of the following: systolic blood pressure is likely to increase. So right now we are looking at it, increase in blood pressure. So we need to see a reduction in diet, less diet, increase in blood pressure. So we're looking at this one. So answer choice A says mild hypertensive on a normal diet, change to a combination diet. That answer choice A is an increase in diet. That leads to a decrease in blood pressure. Okay, answer choice A is incorrect. Mild hypertensive on a combination diet, change to a normal diet. That's less diet. So that's an increase in blood pressure. And we could even say to the degree that there is a change in the systolic for mild hypertensives, because we know that it will decrease by 11 meters of mercury. So that means if we're going in the opposite direction, in which the person is changed to a normal diet, that means it should, on average, have an increase of 11 meters of mercury. And then answer choice C, high normal blood pressure on a normal diet, change to a combination diet. That again is going to be a decrease. And then people with high normal pressure on a combination diet, change to a normal diet, that's only 6 millimeters of mercury, not this same significant change. Okay, so let's, again, we're going to move to question number 3. You can put your answer in the chat. So just to state that this is going to be B, we're going on to question number 3. Okay, which of the following is likely to be the best estimate? So as soon as you hear best estimate, you know that you're going to be giving an approximation. So keep that in mind, of the diastolic pressure of a mild hypertensive person. So we are looking at mild hypertensive person on a fruit and vegetable diet. Well, wait, we have mild hypertensive person on a combination diet. We don't have any graphic information regarding a mild hypertensive on a fruit and vegetable diet. We do know that if you go, we notice the trend that combination diet going to fruit and vegetable for a different blood pressure category, we see that there is a reduction in the change. So we are expecting a reduction in the change. The change cannot be this big, but what actual value? Let's look. So it's going to, but the change must be less than this. Being on a diet still means there's going to be blood pressure reduction. So the blood pressure should go down because this person is on a diet. But the blood pressure cannot go down as much as if the person is on a combination diet, because we see this trend here. So what is the maximum effect that this could have? Well, the maximum effect for the diastolic pressure would be 95 minus 6. So now we look at the answer choices. So the maximum change has to be 95 minus 6. Answer choice A is 88. So that's already too much of a change. How could reducing your diet make the change even greater? So 88 is out of the question. Answer choice B, it seems rational. Now, C and D, those were blood pressure increases. So for the diastolic. So that's moving in the wrong direction. So now we have The only answer that we're left with as a possibility is 92, and that's answer choice B. But also keep this in mind. Keep this in mind, because what ACER has done is to provide you information as to what a reasonable estimate would be for the diastolic blood pressure of a mild hypertensive on a fruit and vegetable diet. Now, why is that important? Because we're going to see mild hypertensive on a fruit and vegetable diet again discussed in the next question. So by keeping in mind this diastolic number, this will help us for the next question. Okay, question 4. You can put your answer in the chat. So of the following, again, we're looking at the diastolic pressure, which we just finished calculating. Because keep in mind, some professors never relate one multiple choice question to another, but ACER does. And you'll see this as you go through their materials. So of the following, what is the likely to increase most? Is likely to increase most for a typical mild hypertensive? Again, we're talking about starting at 150/95, just like question number 3. On a combination diet, changed to a fruit and vegetable diet. Well, we just finished calculating that combination to fruit and vegetable, which is answer choice A, is a difference of 3 units. So that's the information that we just determined. And then in answer choice B, we have mild hypertension, fruit and vegetable change to a combination diet. Well, you just increase the diet, you will have more you'll have a decrease in the blood pressure. So answer choice B is relating to a decrease in the blood pressure. And that's by our rule. Now, answer choice C, let's just analyze it. Person with high normal blood pressure. So we're talking about here, high normal blood pressure on a fruit and vegetable diet is changed to combination diet. So what is the difference here? The difference is for diastolic, we have 1 going to 3. So I'm just going to put in parentheses here, C is a change of 2, which is less than A. So A is the winner. And then answer choice D, again, is presenting with a decrease. Okay, so we have those, and then we're going to go on to question number 5. And 5 presents additional information. Now, in the olden days, in these booklets, additional information is provided as an additional paragraph. But on the new digital exam, computer-based exam, some students found it off-putting the first time they sat the exam, is that there's a tab at the top on the left-hand side of the screen that says additional information. So when you require additional information, you click on the tab and it reveals the additional information. Of course, you're going to see this when you try ACER's online exam or when you try the Gold Standard or Master Series exams. You'll see that additional information tab, and you'll just get used to that. So now 5, we're providing that information, additional information, and we have a new rule. And sometimes it's helpful again to write out what that rule is. So first of all, with respect to the sound, we start off with a period of no sound, then we have sound, and then again, there's no sound. That's the information that we are provided. We're provided that we occlude it. Okay, so when it's completely occluded, that's when there's no sound. Then there's a period of time where there's a partial occlusion, and this is where there's sound. And then there's a period of time where it's just open and there's no sound at all. And I can just very quickly in 3 seconds do some, or 5 seconds do some special effects. So there's your artery open, and there is no sound when it's open. And when the blood pressure occludes the artery and presses it there's going to be sound, and when it's completely occluded, there's no sound. So it is quite intuitive. No sound here, partial, and then completely open, no sound. So that is the basic idea. Now, if you've done your physics, you might realize that when you have a complete open, the blood is flowing easily, and that's called streamline flow when it's like this. And then when you have partial occlusion, it's partly closed, there's resistance, the blood is hitting that and making that sound that you can hear with the stethoscope with nurses know you're occluding the brachial artery and you're listening it to in the antecubital fossa, which is all irrelevant, but are words that you might see on the exam. But you can just regard that as blah, blah, blah. And so the first event, as we are told in the little passage, is that we are having a systolic blood pressure at the higher pressure, because this is occlusion. That's really high pressure. You occluded it completely. You added a lot of pressure. And then later, just before opening, that is the diastolic pressure. So we sort of keep those things in mind as we're looking at the answer choices. And you can put your choice for answer question number 5 in the chat. So the pulse sound disappears. So this is where it disappears just prior to opening. And it talks about the force of ventricular contraction, but we are not provided sufficient information to be able to see exactly what happens to the ventricular contraction during all of this. And nonetheless, we'll keep it in mind as we look at the other questions. Then it says diastolic pressure declines below a certain level. Again, change in the diastolic pressure for the person, for the whole body, as we're occluding one artery. We don't have information about that. Systolic pressure equals diastolic pressure. In medicine, there's a technical word for this. It's called death. And so if your blood pressure, if blood is not circulating throughout your body, then of course you're not getting oxygen and the removal of carbon dioxide. You know, keep in mind, fluids will move from a region of high pressure to low pressure, just like you see in general chemistry. Substances move from an area of high concentration to low concentration. So this is normal. And then finally, arterial occlusion ceases altogether. So this is the point at which that is true. So 5 is indeed D. And then finally, suppose the cuff pressure was 140 for a typical hypertensive person on a normal diet. So hypertensive person, a mild hypertensive person, just to be sure. And so we have 150 over 95. So we have a systolic of 150, and then we have a diastolic of 95. So we have, suppose the cuff pressure was at 140. So we have a cuff pressure in between here. So 140 millimeters of mercury. So it will be heard throughout most of the cardiac cycle. Well, as you have partial occlusion of the artery, what you're hearing is that turbulence, energy being converted into sound as it's hitting that obstruction, and it's hitting it every time your heart beats. Boom, boom, boom. And so that means it's hitting that occlusion once every time the heart beats. So once for the cardiac cycle. And that is indeed answer choice B. Now, the other ones say that this will not be heard because the cuff pressure is too high. But if the cuff pressure is too high, then we have full occlusion and there is no sound. So if the cuff pressure is too low, that's below the diastolic pressure. Too high is above the systolic pressure. So Answer choice, question number 6, it's good for you to look at it and see that C and D are an exact opposition, and yet C and D are both wrong. So you can't take that little high school advice that, or secondary school advice that some teachers say that if two things are in opposition, then it's probably one of those, not necessarily through true for ACER, who realizes that some students are using tools like that or ideas like that. Okay, so we have 5 more questions, and these are going to be completely different, and they also deal with circulation. But there is one thing I'd like to say just before we start those 5 questions, and that is that is about this rule that keeps you on track for this unit. And I'm not saying that this is the most difficult of ACER's units, not at all, but it does underline some very important themes. And that is that during the exam, you might have something either in the humanities section or in the science section that requires you to write down the rules. And the words here might be, they might sound like Martian to you, you know, a topic that you didn't study. And then you might feel insecure about it. You might feel, oh my goodness, I didn't study that topic. And now they're asking me questions about it. But they're not asking you questions about it. They're asking you, how do you think with the content that's being provided to you? So even if the words are blah, blah, blah and zabada, it doesn't matter. Just put them down, show what the rule is, and then look at the questions and see how those rules apply. Don't feel that there is some deep knowledge that you needed to know about blood pressure or fluid mechanics or anything else. You're using your thinking techniques. Okay, so let's move on to the 5 questions. If you can please provide the link, and if you're watching the video, the link will be in the description. And we also will need 10 minutes. Now, some of you who are taking the tutorials, the 3-hour tutorials, a couple of the questions you may have seen already. And if so, then you should work on something else during that period of time. Okay, so 10-minute timer. Please begin now. Good luck. Okay, so this is called a nomogram. It's a type of graph that has more than uh, two variables. So you're used to seeing X and Y, but of course here we also have a second Y-axis, and also we have these curvilinear lines that present some additional information. And ACER loves them because most students don't have a lot of experience with nomograms. And so ACER likes to use them in many different ways. So just looking, at the caption, X and Y axis, all the intervals are appear to be the same. Okay, and also just from general chemistry, I'm putting this in the back of your mind. It's not very important right now, but of course, because pH is equal to negative log hydrogen ion concentration, as the pH is increasing, the hydrogen ion concentration is decreasing. So these are moving in opposite direction. And remember, of course, ACER loves opposites. When they get tired of opposites, they'll have a question on the opposite of an opposite. So nonetheless, so sometimes ACER, when they're presenting to you a graph that you may not have seen before, sometimes, not always, they will give you a data point to help you orient yourself, or they'll just ask a very simple question. So the data point that was provided in the paragraph above the graph is that at a pH of 7.4, so here we have a pH of 7.4, and a bicarbonate, which is over here, of 24. So we go 7.4 to 24. So here we are, that this is a normal value. So we see 7.4 to 24 is a normal value. What's also helpful about this data point that they're providing is that it says that at this point, the PCO2, or the partial pressure of carbon dioxide, is 40. So this helps to orient you because you see this point here, but then you see this along the line, and that leads to 40. So that you know that these curvilinear lines are intersecting with other lines. So that's the main point. So that's how you are able to get oriented sometimes when they provide you with some additional information. Okay, so question number 8, you can put your answer in the chat. According to figure 1, an arterial blood pH of 7.5. So now we're moving over here to 7.5, and PCO2 of 25. So now we've learned that this, do you see how there's an arrow pointing PCO2? So these are the curvilinear lines. So PCO2 of 25. So we're going to follow 7.5. We're going to follow 25, and they intersect right here. And it asks, what is that region? And that is clearly acute respiratory alkalosis. So for question number 8, we have answer is B. And then we move on to question number 9. Consider a patient with metabolic alkalosis. So we have metabolic alkalosis up here, and we're going to move that patient to normal. So if we're moving this patient to normal, what are we doing? We are going to reduce the bicarb because we're going from here to here. So bicarbonate is going down. So we look for possible answer choices, and you can do your answer choice for question number 9, as some of you have done it already. Put your answer choice for question number 9. We have the bicarbonate is going to decrease, and as you go down, bicarbonate is decreasing, but you're also moving a little bit to the left. You're going from metabolic alkalosis to normal, and that means that your arterial blood is going to increase. You see the numbers are increasing in this direction as we go here. So for question number 9, the answer is A. So I'm sorry I'm going a little bit quicker than normal, but there's next step. And by the way, if ever you have any questions about any of the questions that we do or the work solutions, you could always post them in GAMSAT-prep.com/forum. It's a free forum, and you can post your questions there, and you usually get a response within a day or two. Okay, and then question number 10, based on figure 1, which of the following is directly correlated with an increase in severity of metabolic acidosis? So directly correlated, what we're looking for is we're looking that when metabolic acidosis is increasing, then this other thing, whatever it is also increasing. So we want to see that as a trend. So we have metabolic, just make sure, metabolic acidosis. So we have metabolic acidosis over here. And so here's normal. So metabolic acidosis is getting worse. So as we go in this direction, we have metabolic acidosis getting worse. So what are the changes as we're going from here to here? You can put your answer in the chat. So what else is increasing as we go from here to here? Well, as we go from here to here, we can see that the bicarb is decreasing as we're going in this direction. We can see that the pH is decreasing as we go in this direction. We see a general trend of the PCO2 also decreasing, not in the same direction. But as we go from normal to metabolic acidosis, we see that the arterial blood is, blood concentration, hydrogen ions, is increasing. So it's moving in the same direction as the metabolic acidosis. No surprise, acidosis. And so here we have answer choice C as the response. Okay, so now let's move on. Again, we have the same terms that we saw in ACER's unit with cardiac cycle, diastole and systole, but these are just decorations to seeing how you reason. So here's the graph. We have the caption that you can read. You look at the values, and then you look at the answer choices. As a general strategy for the exam, in order to increase your time efficiency, it's very helpful to just look at the questions stems first, glance at the answer choices before you do complete the unit. You're going to find that sometimes ACER presents a graph or a table, and then there's no, I know this sounds crazy, but there's no questions based on either the graph or the table. Yeah, I mean, no questions. You're going to find this in GAMSAT Practice Test 3. I'm sure most of you know that I put the step-by-step work solutions to those on YouTube for free. And you can go through the reasoning, but you'll see that sometimes ACER presents information that's not used to answer any of the questions. And so you can imagine some students trying to understand a graph, but then there was no questions on that particular part, and then they wasted their time. And in this instance, there are questions, but not on everything. And so you didn't have to understand every part of the graph in order to be able to answer the questions. Nonetheless, so now we're going to apply something called dimensional analysis, which is a very helpful, useful technique in physics in general chemistry as well, and also in GAMSAT biology. You're going to find this. So which of the following is most consistent with the heart rate in figure 1? So we get information about the heart rate, which is typically expressed in beats per minute. So we would like to find out how many beats per minute do we have based on this graph. But what we don't have a direct information about that, but what we do have, so I'm just going to write that down, that we're looking for beats beats per minute. Oh, by the way, for question 11, you can put your answer in the chat. So we're looking for beats per minute, but what we have is we have a tracing that's showing us three beats in this information provided that are occurring in 1 second. So that's all we have. We have the information of 3 beats in 1 second that's provided, more or less. It's not exactly precise, but it's quite good. So we have 3 beats per second. And by the way, we're able to say more or less because the answer choices have significantly different ranges. So we have 3 beats per second, but we want beats per minute. So we need a conversion factor to do that. And so we can say that there are 60 seconds in a minute. And so the seconds cancel. That's dimensional analysis, paying attention to the units in order for you to get what you want. You end up with beats per minute. So now we have the complicated equation, 3 times 60, and that gives you 180. So the numbers are very far apart. And so we're able to get 180 beats per minute. And so 11 is clearly over 145. And now for the one that you may find a little bit more challenging, which just, again, is just using dimensional analysis, virtually no assumed knowledge, but you have to use your reasoning skills. Okay, according to the information provided, determine the approximate volume of blood in liters that is carried by the main pulmonary artery in 1 day. So you can put your answer in the chat for question number 12. Okay, so let us begin. Now, some of you will get tripped up by this question for various reasons. But first, we are being asked about the pulmonary artery. So we do have information. We're looking for volume. We have the amount of volume per minute. Now, when we look at this, we can see that the intervals are 700. They're not all written, but you can see the intervals are 700, 700. The implication, this must be over here. This must be 4,200. And some of you will use this value, 4,200 centimeters cubed per minute, in order to get your answer. But that's incorrect, because is the flow in the main artery always 4,200? Every single second, it's always 4,200? Because if you're trying to calculate the total volume, then you have to go according to what is the flow. Well, sometimes it's 4,200, sometimes it's 0. Sometimes it's 4,200, sometimes it's 0. So you can't use 4,200 because that's a completely different situation. The blood pressure is being maintained, and that means systolic equals diastolic, and that means death, as we saw from that ACER question. But it's going up and down. So if it's going up and down, we can say, okay, on average, it's 2,100. Now, is that number perfect? No, it might be somewhat less, somewhat more, but wait, look at the answer choices. This is more than twice that. We're not doubling anything. We might be off by 10%, 20%, 30%, but we're not doubling something. And then this, well, forget it. We're talking about we're talking about an exponential change in the values. So it's very reasonable to say 2,100, but let's make it a little easier. We'll say 2,000. So we're going to approximate it as, on average, there's 2,000 milliliters per minute. Now, yes, I did change, because I'm familiar with SI units. I did change centimeters cubed, can also be written as cubic centimeters, a cc, but it's also can be written as milliliters. And why am I changing cubic centimeters to milliliters? Because I might not do it all the time. There might be a question that's in true SI units, which would be meters cubed per kilogram, or per minute, or per second, or something like that. But I'm changing it to milliliters only because the answers are in liters. So I changed that to 2000 milliliters, and milli means 1,000th. So I'm going to say use instead 2 liters per minute. So now we have something that we can work with. I want to know how much in one day. So I need to convert 2 liters per minute to the volume per day. So let's try. This is dimensional analysis. I'm setting up the calculation so that I can get the number of liters per day. And that's what I want to end up with. So I have 2 liters per minute. And so I can convert this into hours with 60 minutes is in an hour. And then I have 24 hours in a day. And of course, I'm not going to work with 24. You can if you want. It's up to you. But let's be honest. As I said before, the difference is not 10% or 5% or something like that. It's double, and then exponential difference. So if during my calculations, sometimes you may be able to convert 24 to 25, or you may be able to convert 365 days in a year to 400 days in a year, depending on how close or far apart these are. Don't forget, no calculators for the exam. So I have 25 times 2 is 50, and then times 60. Now, that's not the hardest calculation that you're going to have to do. So we have 3,000, and that's 3,000. We have 3,000 liters. So, by the way, this is called dimensional analysis, making sure the dimensions do its job. And then this is just the mathematics. And so we have 3,000 liters per day. And of course, that's 3 times 10 to the 3. Now, if you used more precise numbers, then you can get the precise answer. But why would you do that? You want to be able to use values that increase the speed of your calculation. So those questions are from the Master Series book, and I hope you find them helpful. If you have any questions about the questions, please go to our forum, and also, please acquire all of. I believe you should acquire all of ACER's practice materials. Go through them. Most students don't find going through them multiple times to be helpful, but rather the most important technique is that you complete the practice questions, preferably timed. Then you can go through them and take your time to make sure that you've done them right. And then after that, after you've completed the practice question, you take very brief notes regarding your experience. What did you learn? What mistake did you think? What did you miss? And you put that in your notes. And those are the notes that you study from every weekend, a couple of months before the exam, and then 2 to 3 times a week as the exam itself approaches. And you can convert those notes into other formats, study cards, audio files, whatever helps you to study. So this will be you'll be able to get this after on YouTube, and yeah. So I'm gonna have to get in the habit of saying things that I'm not comfortable saying, but yeah, like, comment, and subscribe, and that will be helpful when you do so. Okay, that's it for today. We're going to be back in a couple of weeks, and we're gonna keep going through these units. As I said, all the work solutions are there already, but if I can give some new angles to it, I think that may help. And also, Did you notice all those 5 units were about circulation? And how much did you need to know about circulation? Almost nothing. So, and and also notice how different the questions are from each other. And yet they may be, it could be said that they are about circulation. They're very different from each other. And that's how the real exam feels. It feels, this unit feels different from what I've been doing before, but the logic and the reasoning used, that is the common element. Okay, that's it for today. Good luck with your studies. And for those of you in the tutorials after, we'll be starting in 2 minutes. Bye for now. Thanks for coming.